So thank you everybody that's here. Thank you everybody that's online. I thought I had an hour to talk about all this stuff, and but it turns out I have a half an hour. So we're going to blow through some things. The best way to get in contact with me is my phone number, which is area code, country code 1-919-360-3840. Also Brooke, B-R-O-O-K-E at robin.io. For any of those people filing in, I've got business cards for you as well. So let's get to it. I'll probably run a few minutes over, and I will be available after for questions. So I had to cut out a bunch of slides to fit this next and a half hour. So you're like, why are you starting with this with such a stupid slide that says nothing? Because this is the crux of my argument. I get a lot of RFIs, RFPs, and it's a bunch of checklists. Because people are used to asking for checklists, they're used for the status quo. So do not ask me what I do. Ask me why I make it better. Ask me how it works. So how many people do we have here that are deploying services? All right, we got a lot of people, so that's good. And all I have to say to you, and this is not meant to be negative, don't ask me for like 500 specifications that I conform to. Because let me give you a use case example. I have one customer that I worked with recently. All they really wanted, they asked me for 5 specifications, but all they really wanted when I talked to them is they said, with your Kubernetes, can you run the following VM using their proprietary VNF manager using an Etsy interface? Which is pretty simple. It's like, you know, because for some reason this was an old application that was kind of built before all the Etsy standards that was eventually grandfathered into the Etsy standards. So they asked me for about 5 or 6 specs, and all they really needed to make sure was that I could deal with the standards-based API to run things through the VNFM because they didn't believe that their application would work any other way. So the big thing is that will help everybody, and again, it's not a complaint of being a vendor, is it's not just what you want to do, understand how you do it. Because you should not be expecting the status quo. If we're talking about changing the entire infrastructure with things like Kubernetes, we should be able to change your automation to make it unsuck. There are things that you know that you don't like about your current automation, and you should expect them to go away, not perpetuate design after design. I'm going to go really quickly over this one because of time. You know what your edge use case is, but I think one of the big things about almost all of these use cases is that they are stateful. They are not stateless. When we look at all of the classic things in the core for Kubernetes, it had to do with stateless applications. I would read articles about how everybody needed to rewrite all their applications to be stateful, and if you didn't, you were breaking some kind of cardinal rule. It was a capital sin. But as we see that there are many things that need to be stateful. And again, what is stateful? And the easiest way I can put that is, if you look at something that's stateless, I think of a calculator with no memory, where all it cares about is today I ask for what's 1 plus 1, tomorrow I ask for what's 6 plus 8. Or you look at your old school browsers before everybody started stealing your data, all they care about is what you ask for now, not what they ask for later. Whereas a great example of a stateful application is your bank account. Your bank account wants to keep and maintain everything you've ever done to the edge of time. And when you look at a lot of these things, we're talking about stateful data, and that adds a lot of implications to anything you're doing with automation. And when I think the common challenge of looking at things in the edge, of course, location is everything. For instance, and this will happen, we will see in our lifetime smart cities as an extreme example. You're not going to have your IT guy standing there by every smart stoplight or every video camera, right? You don't have IT everywhere that you need them. You have limited IT resources in order to scale to do this. You're going to do a lot of processing and decision making at the edge, and again, that's more stateful type of applications, right? So you have certain needs there. One of the things that I really want us to think about is don't accept somebody saying, I've got a single pane of glass. And I'll discuss this in multiple sections. Single pane of glass is just it's kind of like a Band-Aid. I can't think of a good analogy. So right off the top of my head, let's say my loving wife, beat me up every night. and I'd put a Band-Aid on every night, and we'd think it kind of fixes it. But if that was the case, I'd have a terrible underlying problem. A Band-Aid's not a fix, right? The fundamental problem would be my relationship with my wife. So if you have 20 or 30 existing tools that all are separate applications with separate databases and separate APIs, and someone comes to you and says, we've got a single pane of glass, that is a symptom of an underlying problem that something is not unified. And this is extremely important at the edge, because when we're talking about the edge, I can't just add another rack. I can't just add another row. When we're talking about the edge, I need to be extremely efficient. And just saying that I have a single pane of glass isn't going to cover it. Next thing, as many of people here are going through Kubernetes, again, don't accept the status quo of your automation. You know, challenge your vendors. All right, it's like you're having this completely new paradigm, so why isn't there a completely new paradigm for my usability? Right? It should be, if we're making these leaps forward, my automation should be easier. And this dovetails into the second one of transitioning to new methods. It's, if I have the old solution and I have the new solution, I should not have these immense operation silos. And we'll talk about that a little bit later. Last but not least, the need for better data management. We'll talk about that in the Kubernetes section. But fundamentally, Kubernetes does not manage your storage, does not manage your BCDR, your backup recovery, your business continuity. So somebody, and a lot of times what we see legacy storage vendors is that they say, well, we've got a CSI, so we're Kubernetes compliant. That doesn't mean that it solves your problem. And we're going to talk about that in a little more. So when I break these things down, we have end-to-end automation, we have issues with Kubernetes, and we have issues with brownfield. This is very much a chicken and the egg discussion, because to discuss end-to-end automation, you need to understand your Kubernetes, you need to understand your brownfield. So I tried to put these in some kind of logical order, but again, to discuss one, you kind of need to know of all of them. So eventually I'll touch upon all these in my own way. So let's talk about end-to-end automation. Just always give my time check here. All right, so what are our big challenges? So one of the things, when we look at the edge, there's an entire solution stack. We need to figure out how to look at the entire solution stack in a different way. We shouldn't have 50 million tools, and this is probably what I'll go into the deepest detail in our next slide. All right? We need to make sure that when we're doing this, again, we're not accepting the status quo. I shouldn't have 40 or 50 tasks to do with 5 to 10 tools. We need to find a way to unify this, again, not just under a single pane of glass, but in a unified way that reduces the number of workflows. And also, we need to move away from something that says, well, if I need this, you write a script. If I need this, you write a script. If I have a change on this one, maybe I need to write a script with some different IP addresses, and I need to have some tool on the back end where I can set up some variables and it figures out how to do that kind of thing. In the example, I always think that I had when I worked for a large vendor 20 years ago, I was in a conversation with a guy from Pac Bell, if anybody remembers what that even means. And we had like a bunch of product managers preaching to him, and he stops this poor unfortunate person, says, look, man, I don't want to hire a CCIE, which is a very smart, it's a certification worth getting, but it's a very smart, highly trained, highly expensive person. I don't want to hire CCIEs. I want to hire kids that are really good at playing video games. And it's one of those moments to me that I always go back and think on that. It's like I should not have to be an expert to run this stuff. It doesn't mean that you won't have a couple of smart people under the covers working on some of these things, but everybody shouldn't have to be that smart. We also need better observability that's unified, because if I have 20 or 30 different tools, then that means I've got to hire a whole bunch of people to manage databases, manage analytics, do a bunch of screen scraping or database scraping, and figure out how am I going to present this to the user in a meaningful way. You shouldn't have to hire those people. You shouldn't have to pay for that. That should come along with it. Business continuity is a bigger one as well that we'll talk a little bit more in the Kubernetes section, because the things, we kind of changed the model with this whole disaggregation and containerization approach. So, just simply backing up storage doesn't quite cut it anymore. And last but not least, when we talk about scripting, if you want to burst from the edge to the cloud, let's say that you have an outage that let's say honestly, someone just blows up your edge site, or your edge site goes completely down and you have certain customers that you have to service. Well, you may need to move it somewhere in your core. You may move it to somebody else's core. And this shouldn't be a major fire drill. This should be something that's easily modeled. You should be able to, your policy engine should be able to look at and say, I lost connectivity to all this stuff. And right before it, I saw some symptoms of catastrophic failure. I should be able to easily migrate all of my customers to some other site. All right. So this is a slide that I could talk about for the whole half hour. I'll try to keep that simple. And I picked a particular use case of edge applications on a RAN, because that's about as difficult as I could think of to make the solution. So I have a whole bunch of data centers everywhere. And I apologize for some of the shameless promotion, but I'll try not to talk about our stuff. Try to keep on topic. So the first thing is I have a bunch of bare metal servers. I can't do anything until my bare metal servers are updated. And there's a lot of drift that can occur with that we'll talk about in a second. Then on top of that, I need to put my cloud layer, which Kubernetes is what many people, or just about everybody's migrating to. And I can't even install that cloud layer until I have the right bare metal layer in place. And I need some applications before I put any of my core network functions on. And one of the things I remember back in the OpenStack days, and I'm getting ready as a product manager to go in the lab and work the product and show everybody that I'm not some guy that just gets up in front of people and talks a bunch of nonsense. I'm like, okay, there's all this Linux stuff, and I'm old enough to say that I used to use Unix, which we know is Linux is based off. So it's like, okay, I can make my way through this. Then I looked at it. In order to set up all this stuff, I needed all these supporting applications in places. I need things like message queues, and I need databases, even before I can just install the OpenStack Cloud platform. Right? And this is to say that if you want to deploy something, there's a lot of stuff you need to have in place. For instance, if you want to have an automation pipeline, and I'll use this example, you need to have, typically a lot of people use Kafka these days as a data bus where I can subscribe to a topic to listen to. So before I can even deploy my critical service that I'm making money on, I have to have a bunch of supporting applications in place. Once I do that, I need to have my core network functions, in this case for my RAN, and then I have to find a way to stitch them into services. And again, this is not a place where I can do a lot of things with Kubernetes, but it's really not tons of service oriented. And when we look at a lot of things that we're deploying, it's more about, I have an application or a network function, and I need to make sure that it's on the right virtual network and I have the right addressing exposed, and then it figures itself out. And kind of that's what we call service stitching. Rather than to say, I need to stitch A plus B plus C plus D and make it go, I need to do a whole lot of other stuff to enable it to get ready. It's not simple. But we're not done yet. What we call methods of procedures, which is a term that I really learned when I started working. But what it means is there's a lot of other scripting that we need to do. So if we did everything services to bare metal, do I have a service? The answer is absolutely not. I've got to enable something top of rack. I've got to say enable something end of row. I've got to make sure that my load balancer is placed. Maybe I need to send something to an SDN to make sure we're connected. There's a whole bunch of things. And we can use this for other things like text messaging people that the services are out. If I have some kind of patches that I've got to meet, I can use scripting to do that. But if I want end-to-end automation, it's more than this stuff that we typically talk that's just the virtual IT stuff. There are physical devices, there are appliances that need to be in place. And last, I need to make it observable. I need to make sure that all of this stuff is in some kind of inventory that I can manage. All right. So if we look deeper under the covers, there's a lot of work to be done. A lot of silos. Anybody that's worked with in the RAN is, like I think is a good example, is that these network functions are highly specialized. You have to be on the exact right server model. They're highly finicky because you have to do a lot of real-time stuff with low latency. So I have to have the right the right operating system. I have to have the right BIOS. And there's a number of things that your vendor will say, well, we're not going to support this unless it's done exactly right in hardware. Plus you have this problem, you know, and this has been a problem that was around before bare metal servers, that if I've got tons of site, I'm dumping hardware out there. You know, and then I'm going through and I'm turning everything up, and when I get halfway through, I'm like, oh, okay, my application, we found some bugs in it. I need to upgrade the OS. I need to upgrade the BIOS. Oh, by the way, there's a security patch. So somewhere in this massive rollout, you're going to realize that the stuff you have in bare metal is no longer good enough. So you're going to have to go through and you're going to have to change a number of things, because you don't just deploy all the hardware in one day and deploy all the services in a day. We also have cluster issues. The cluster, you may have multiple distributions. You may be working with a cloud vendor that has a specific Kubernetes distribution you want to deal with. And you know that the same cluster size or the same Kubernetes configuration you have at the edge is absolutely not going to be the same one you have at the core. You're going to have, certainly going to have a different number, fewer number of physical nodes, a different configuration for HA. So you're going to have multiple of those that you have to deal with. Same thing with applications. You have to worry about how you're going to install it. You're going to have to worry about how you start, stop, and heal it before you can do your network functions that have the same problems. You're going to have to stitch these all together. You're going to have to make sure that the rest of the network works, and you're going to have to map it to inventory. So I haven't counted it up, but each one of these are critical tasks. That's a lot of work, and if this slide looks tedious and ugly, that's the point. I've got another ugly slide coming up later. So that's a lot of work. A lot of times in places, this is a team, this is a team, this is a team, this is a team, and I have many, many tasks that I have to go. So wouldn't it be nice if I can say, this is all I need. I need something that simply does bare metal, something that does cluster, something that runs all of the other stuff. But you know, you shouldn't be happy with that, because again, these could be multiple tools, but under a single pane of glass. But each one of these has different design constraints. So when I want to make a change to one, it's going to impact all the others, and you got to get a lot of people involved. I mean, what you really want is for it to be unified under the covers, where things use common databases, where there is a design rule for everything, not for tons of things. So while this is much better than what we had before with 50 million manual tasks, we can do better, because if we can get it to this level, we should certainly be able to get it to this level. I should be able to say, if you want to deploy a RAN, here's the multi-domain workflow. After I've done that, the customer says, you know, I want all this stuff to come up together, because individually, each one of these layers are tasks that people are specialized in and can deploy easily. But we want to do it all at once. So let's deploy the RAN. Someone wants private 5G? That's another service we add on top of it. Someone wants a MEC app, mobile edge compute app, we can deploy that. Someone wants just any general app. It all should be that easy. And you should be demanding that it's that easy. If we're going through all this innovation cycles in technology, you should ask for innovation cycles and automation. Just giving myself a time check. So how do we make that work? Your interface should look like this. Right? Your interface should not look something like this. Right? If someone's going to operate it, it should be easy. I should not be a Kubernetes expert. I should have an app store type experience. But I realize that that could be a further simplification. So you should have and again, I wish I could go into the slides in more detail, something that looks like a worksheet. But in this worksheet, it's asking me things like, okay, if you want to deploy an analytics pipeline, what else do you need deployed before that? Well, maybe I'll need Kafka, maybe I'll need a database. What's the affinity? Do I want my compute and storage to be on the same node for maybe optimal performance, or do I want to do things for redundancy? And you accomplish this, instead of worrying about individual solutions, you model the solutions. Look for something that actually does the modeling. Because what this enables you to do is, again, you don't have to have expertise to operate it. Someone can say, I expect my automation solution to find the resource for me. You should not have to hunt for the right resources. You sure as heck should not have to hard code and manage all the hard coding things like IP addresses across all those. It should make your life easier. And then that makes it easy to deploy from the test site all the way out to the edge. If you have some kind of bug you want to reproduce, you should be able to easily get that from that environment to your testing environment. Then you fix it, push it out. Again, you want to ask for more. You want to understand how it works, not just what it does. So let's talk about Kubernetes. This is my big pet peeve this now. Footprint. Everybody and their mother is talking about their big solution that took 1 million cores and like all the memory in the world to operate. It's like, okay, well, we run it on 2 cores or we run it on 4 cores. But when you ask them what comes with that, it's like, so how'd you do that? Well, it has everything you love, but we got rid of all the API, most of the APIs, and we got rid of all the operators. So that doesn't tell me it has the same stuff we love. It tells me that you just have something with no functionality that sits at the edge. Now, there are some use cases where that is certainly applicable. But when you look at things like ease of use and observability, and working with all your favorite applications, that's a no-go. So we don't want to get stuck into that. We need to worry about stateful applications, numerous things with application persistency. We want to have things unified under the covers that I've talked about a couple times, because I don't want to have to worry about 50 million design constraints, especially at the edge. And then a big one when we talk about stateful application is how I do BCDR with storage, and I'll talk about it on the next slide. Like a lot of vendors are saying, your legacy storage vendors will say, well, we've got a CSI, so you're covered. CSI doesn't do a whole lot. I wouldn't proclaim to be an expert, but you can mount something, unmount it, you can make a persistent volume claim, but it's very, very trivial on what it does. But because Kubernetes doesn't handle that, and the CSI is a way to offload that. And ourselves as well, and there are a couple of vendors that do things a lot better than what a traditional legacy vendor has. So you need some kind of smarter software-defined storage layer on top of that. And the big thing is, again, how something works in terms of checklists. Test the heck out of it at scale. There's a lot of things you can do in a lab. For instance, there's one company that does a lot of stuff in memory. So you can say, see, look, it runs faster than your bare metal storage. Well, yeah, because you have a small piece of the database in this test and it's all in memory. So of course it would do that. So that dovetails a lot into BCDR. I think just about everybody's got a lot of the advanced networking thing solved, especially for more service provider applications. We have overlays and underlays, different ways to figure IPv6. Understand how they do their resource pinning and resource sharing, what kind of multi-tenancy and RBAC they have, and what did they do for a workload mobility. Because again, everybody will tell you that I can migrate from this cloud to that cloud to any cloud. But again, the question is how easy to that? Again, am I getting stuck in a bunch of pile of scripting? Or I can do something based on a policy where I don't need human intervention, where I can have a policy engine saying, I see the following problems at my edge site. I need to migrate to a different rack, a different row, a different site, or maybe I burst out to the cloud, etc. So I wanted to have a big visibility exercises where we all held hands and sing songs, but I'll have to kind of put this. So let's imagine we're all here to solve a business problem today. And it's a really noisy room and it's in the dark. And the only thing you could do is touch each other. Now chill out for a minute. So let's say, everybody's holding hands. Unless you're Helen Keller, who was, really good at that kind of communication, what could you tell by that? You could say, well, I could probably tell if I'm holding a guy's hand or a woman's hand. If they had certain calluses on their hand, I could tell if they did manual labor. And if I pull on somebody, I could maybe make some gauge of their overall size and their overall fitness. And And with storage, if I say I just have a CSI, that's kind of what you get. You get holding hands. But imagine then if I turn the lights on and you can see each other. You could see like, okay, I recognize some of these people in this room. I can see I've got this guy up here talking about automation. You'd know where you are. Or you could see I'm with my colleagues and we can get some work done. And then imagine if loud music turns off and you can talk to people. So when we talk about storage, that is extremely important. And so when we looked at legacy bare metal or VMs, it was a very simple relationship between my application and my storage. It's a one-to-one mapping. If I backed up my storage, I'm pretty darn good. I could do a lot of things, and that model has worked for decades. But with Kubernetes comes additional challenges, and I talked about a database app. So first of all, the application is broken out into multiple containers or microservices. For this example, I chose 4. I realize people will say that's not really a microservice, but I didn't have enough room on the slide. And I've got a bunch of containers that I can scale out in those roles that will scale independently. Plus, I can have multiple versions of that database, and I can load balance between everything. Then I can slice and dice it based on, different nodes, etc. I can have horizontal, vertical slices and how I wanted to manage that in terms of my redundancy. So automatically, I'm way more difficult than what I've got there. Plus, each one of my containers has a different relationship to my storage because they don't do the same thing. Same thing with my compute resources and the same thing with my networking. So I have both both underlays and overlays and virtual networks that reach up into there. So this is quite a mess. This is very different than what I've had here. And so why do you give a crap about that? So in essence, if let's say I have a volume that spans multiple media types and I need to quiesce that. So when I quiesce that, it means that I take all of my data and I get it to the exact same point in time before I take a snapshot or I do a backup, right? Because if I don't do that, then somewhere down the line, I'm going to get burnt. And I guess the point that I'm trying to make is that if you just have a CSI that only understands that I can connect to data or I can make a permanent persistent volume plane to my data, it doesn't see any of this stuff. So it doesn't understand that I have an application that's in a certain state of scale. It doesn't understand all of the metadata that I need to put together. It doesn't stand all my secrets. So you no longer want to just snapshot your generic data. You need to snapshot your Kubernetes application. You need to understand it. And if you want to do that, well, you should probably have some more APIs that understand the actual environment that you have, right? Because I've got a whole bunch of things that I need to keep in track of now. So I guess what we want to say is that, I've got a lot of things that I need to manage. Just backing up storage is no longer good enough if I want to have really accurate data for something like a banking application or for any of those real-time things that will kill you if they don't work right. I don't want to have drones smashing into buildings. And I can't say, well, just revert back to your day one script, because the moment you launch Kubernetes, the state of your application is going to change because it's going to grow. It's very organic. I also need to make sure if I've got all that stuff on the previous part of the slide that I need kind of visibility to debug it on how it all comes together. So I need a platform that looks at app to spindle, app to service type of capabilities, and it does that map for me, so I'm not paying somebody to write some things to figure that out. I also need things like performance management, like some IOPS throttling of my servers, etc. And I think the biggest takeaway that I would say to anybody is, so how do I know to do this stuff, right? And a lot of times people are talking to their storage team to make these decisions. And I think when you're looking at a Kubernetes way of doing these things, you also need to make sure that you have your application team involved. Just do it once or twice and see how it happens. Rather than saying, here's the storage, you can use it. Here's the storage services, you can use it. Get your application teams involved, because I think it will be very enlightening. Last but not least, brownfield. one of my favorite ones. VMs and containers, which I've got a slide to talk about, but I'm running out of time. Silos suck. We have people that say, well, I can run, oh, you want OpenShift? Or I'm sorry, you want OpenStack? I can run that. If you want Kubernetes, I can run that. I'll give you the same price for either node, I don't care. And that sounds very compelling. It's like, and whenever you change, I don't care. But there's a lot of things that happen. It's like you are running two systems. There is a price to pay for running two systems, right? You are going to have operations silos. You're going to have resource silos. You know, if you're talking about the edge, who here thinks that they can afford silos at the edge? Because eventually you're going to need to add more stuff to the edge if you're successful. So why do I want to silo my resources, some for VMs and some for containers? Because eventually you're going to have to pay the piper. But one of the things that people ignore the most is operation silos. Things should look the same. I shouldn't have to have two completely different workflows. And I shouldn't have to have two completely different observability suites that somehow come under a single pane of glass. And at the edge, I need to make sure, like in the way I look at it, is all the way down to the Kubernetes worker node level, not just a physical node level, is I will need, if I really want to pack it in there, I need to be able to share resources between both of those down to the worker node level, especially if I'm running VMs on top of Kubernetes. We need to support multiple storage types and multiple models, file, object, and block. I need to be able to have volumes that span all of those. Because again, you're planning for what you think is going to be happening, but eventually it's going to run out. So whatever resources that I put there, I need to make sure that it has access to every application with every deployment type. I need to make sure that things work with my existing procedures. I need to make sure that I have some kind of unified chargeback and billing, RBAC and multi-tenancy. They need to both fit in a unified CI/CD model. And the one thing I talk about is Redfish. And I've been involved in Redfish for many years. And one vendor's Redfish is not someone else's Redfish. So Redfish allows me to go, let's say, interrogate my BMC, my bare metal. And a lot of people, like every standard, they say, oh, we do Redfish. But somebody's Redfish may mean you can look and see what's out there. Somebody else's Redfish mean I can configure half of it. And someone else's Redfish may mean I can configure all of it, which is what you want. And you want a vendor that can work with your hardware vendors to make sure that if you're going to manage your bare metal, that all of the capabilities are there. That will almost always involve, you're going to come up with servers that people don't support. It's just a matter of time. So you need to make sure that you're working with both a hardware vendor and an automation vendor that are committed to working with you to enable your specific solution. Existing executors, real quickly. So, I talked about MOPS. I talked about working with your existing physical devices. You need to make sure that you're not writing some new kind of language. I should work as an automation tool. If you speak Ansible, I should be able to work with your existing Ansible. I should use it as a building block. I should be able to work with your own APIs. I should be able to work if you're doing things SSH. Whatever repo you have or whatever storage you have, I should be able to deal with that. You shouldn't have to change that. I should then be able to take these executors and make some basic functions, like an install, a power cycle, a certain amount of upgrades, a certain amount of patching. And then I should take all of these things and I could take all of these combinations and put them into more complex workflows. And I always think of a more difficult one called network slicing. That's a RAN-specific model that means I'm going to give a customer or a type of service its own virtual network, virtual IT resources, and I'm also going to give it its physical transport. So I think that's like at the higher end of difficulty. But I should be able to change a config with any of these. And it should be easy to use. It should be very, very modular. I'm getting close to the end here. Hang with me. One of my pet peeves that I could spend the whole time talking on is VMs and containers. I don't believe that you should be running VMs on one platform and containers on another platform. So one of the big things that you could do is you could run KubeVirt, which allows you to run VMs on top of containers. Any solution is better than running it side by side, because whether it's KubeVirt or whether it's something else, it should run significantly faster. Our implementation is actually different than Qbert because we've been doing it longer than Qbert, and I can tell you, no bullshit, we run at least 30 to 40% faster running VMs on Kubernetes than if you're running something on OpenStack. And those are backed up by customer statistics. One of the things you need to be careful about, because we talked about checking boxes or doing the homework, is that a lot of people like to say, well, I run Qbert as a bait and switch. And then they convince you that, oh, it's easier to do this siloed model. Because it really gets down to how I'm going to integrate, how I'm going to automate. So it gets, how do I look at this thing at the deeper level? So when you're looking about this, again, it's not about checking the boxes. Can I just run VMs? How does it work and how do I automate it? And more importantly is how do I make sure that my VMs that I've got now actually run? What kind of automation and integration tools does my supplier actually have? Because this is where everybody and their mother differs greatly. But you want to look for something that has no resource silos. It shouldn't matter if it's a VM or container. I should be able to, again, I should be able to have them both running on the same Kubernetes worker node, not just the same physical node. I should be able to pin resources to them, or I should be able to share resources. Because at the edge, this stuff, if it doesn't matter today, and you're successful, eventually it will matter. But last but not least, always the last thing that people look at is operations. I should not have one operation for virtual machines and a different operation for containers. Because what it means is that I'm paying a lot of extra people extra money to do a lot of extra work. And finally, before I conclude, we're always going to get into this, people are going to ask you to do Etsy stuff in your containers. And what I ask people is, when you're asking somebody to do something for you, don't just state a lot of specs. Give them your use cases. Like I said, I had someone that just wanted me to interoperate with their VNF Lifecycle Manager to tell it what to do, but they asked me for 20 specs. And kind of focus on some of the main interfaces between the devices that you may have to communicate with. And another thing is the different packaging. So how do I get from some of the traditional service packaging for virtual machines and virtual services into that? And this is just a restatement of what we're talking about. The two big takeaways are we need to make sure that when we're transitioning to new methods of automation, they're easier than what we had before. We need to, when we're talking about anything that's a stateful application in data, we must do extra due diligence. And I almost came in on time. So I went way over. So in any case, I'll answer questions now. Anybody who'd like to follow up with me, I've got business cards up front. And the best thing to do is not email me, is to call me.